Module 1 Matrices. Question 1. Matrix N lists the number of students enrolled in Year 7, Year 8, and Year 9 at a school. Part A. Write down the order of Matrix N. Matrix N has 3 rows and 1 column. Therefore, the order is 3 by 1. Students at these year levels can be awarded a grade of distinction, credit, or pass at the end of the first semester. Matrix E lists the proportion of students awarded each grade in each year level for English. Part B. Let the matrix R equals N times E. Part I. Determine matrix R. Use available CAS technology to multiply the two matrices. And here we have matrix R, a 3 by 3 matrix. 2I. Explain what the matrix element R32 represents. R32 is the element in row 3, column 2, and it represents the number of Year 9 students who were awarded a credit in English. Part C. The school wants to present a certificate to each student who achieves a distinction in English at the end of the first semester. The printing cost will be $0.25 for each Year 7 certificate, $0.28 for each Year 8 certificate, and $0.3 for each Year 9 certificate. Write down a matrix calculation that determines the total printing cost for distinction certificates. For this, we are going to write a row matrix with the costs for Year 7, Year 8, and Year 9, and a column matrix that shows the number of students who received distinction in Year 7, Year 8, and Year 9. We can also write this as a product between the row matrix with the number of students who received distinction in Year 7, Year 8, Year 9, multiplied by the column matrix with the printing costs for Year 7, Year 8, and Year 9. Question 2. The year level coordinators for Years 7 to 11 at the school are Amy, Brian, Cleo, David, and Ellie. A faulty telephone system means that some of these coordinators cannot directly call other coordinators. The communication matrix M below shows which of these coordinators can directly call another coordinator. The 0 in row D, column A of matrix M indicates that David cannot directly call Amy. The 1 in row D, column C of matrix M indicates that David can directly call Cleo. Part A. Write the names of the coordinators who can call Brian directly. For this, we are going to look in the column with B, and there is a 1 for A and a 1 for E, therefore Amy and Ellie. Part B. Cleo wants to send a message to Amy using the list number of other coordinators. Write in order the names of the coordinators Cleo must use to send this message to Amy. We look in the row for Cleo and we can see that there are 2 ones. So Cleo can call directly David and Ellie. If Cleo calls David directly, David can call directly Cleo or Ellie. So this goes in a loop. Cleo to David, David to Cleo, and so on. So we can drop this one out. Then if we have Cleo to David and David to Ellie, that just adds an extra coordinator between Cleo and Ellie. So we have to follow Cleo, Ellie, and then Ellie can call Brian and Cleo directly. So we are interested in the one that goes towards Brian. And then Brian can call Amy directly. So the sequence is going to be Cleo, Ellie, Brian, and Amy. Question 3. Students at the school who are studying mathematics in year 7 to 10 can receive one of 3 grades at the end of the year: distinction, credit, or pass. A regular transition matrix T that represents how students' grades change from year to year is given below. 4 of the values are listed as J, K, L, and M. Part A. Explain the meaning of the value 0.29 in the transition matrix T. This means that 29% of the students who receive a credit this year are expected to receive a distinction next year. Part B. Show that the value K is 0.62. We know that all the values on a column has to add up to 1. So 0.29 plus K plus 0.09 equals 1. Therefore, K equals 1 minus 0.29 minus 0.09 equals 0.62. Part C. Let S0 be the state matrix that shows the number of students achieving distinction, credit, or pass in year 7 general mathematics at the end of 2017. All of these students completed year 8 in 2018, with a total of 82 students receiving a distinction. Part I. Using this information, determine the value of L in transition matrix T. From the transition matrix, we know that 65% of the students who were awarded a distinction this year are expected to be awarded a distinction next year. Therefore, we have 0.65 times 80, and then plus 29% of the students who obtained a credit this year are expected to obtain a distinction next year. Therefore, we have 0.29 times 100 plus 50 times L, where L is the percentage of students who have received the pass this year and are expected to receive a distinction next year. We add these up, and that should be 82. Solving this equation, we obtain that L equals 0.02. Part 2I. Students must achieve a distinction in general mathematics at the end of year 10 to qualify for year 11 advanced mathematics. All students who completed year 7 in 2017 also completed year 10 in 2020. How many of the year 7 students from 2017 were predicted to qualify for year 11 advanced mathematics in 2021? Round your answer to the nearest whole number. First of all, we can calculate the value of J. J equals 1 minus 0.65 minus 0.03 equals 0.32. And M equals 1 minus 0.02 minus 0.38 equals 0.60. There are 3 years from the end of 2017 to the end of 2020. Therefore, we are going to multiply the transition matrix to the power of 3 by the state matrix S0. And that gives us 87.3537 students, which is approximately 87 students. Question 4. A teacher saves examination questions in a file. There are 2 types of questions: multiple choice and problem solving. Each month, she changes some questions from multiple choice to problem solving, or from problem solving to multiple choice. She also adds 7 new multiple choice questions and 2 new problem solving questions each month. Let Qn be the state matrix that shows the number of multiple choice and problem solving questions in the file at the end of the nth month. Let T be the transition matrix that represents how the question types of existing questions are expected to change from month to month. Let B be the matrix that shows the number of new questions of each type added to the file each month. The matrix recurrence relation below can be used to predict the expected number of questions in the file at the end of a particular month. The state matrix for the number of questions in the file at the end of the 4th month is Q4 equals the column matrix 3814. How many multiple choice questions were in the file at the end of the 2nd month? Let's start with Q4 equals TQ3 plus B. We are going to substitute the matrices that we know. And from this matrix equation, we work out that Q3 equals the column matrix 32, 11. Similarly, Q3 equals TQ2 plus B. So we substitute the matrices we know. And we end up with Q2 equals the column matrix 25.7, 9.29. So at the end of the second month, there are 26 multiple choice questions in the file.